Hi, Morgan here for Onefinity, and guess what? I just made my first wood inlay. And look, I know that for some of you guys have been doing this for a long time, that's really not a big deal, but for some of us, it's kind of a milestone. So would it kill you to be a little more supportive? Anyway, if you've been wanting to take a stab at wood inlays, stick around. We'll do one together. And don't worry about making mistakes. I already made all the mistakes for you. Lots of them. You're welcome. And while I have your attention, I'm just gonna go ahead and get out in front of this. I don't really like how this project came out. Actually, I hate it. It's not because the inlay process on the CNC didn't go well. That actually turned out a lot better than expected. It was my choice of material that kind of ruined the project. So I did a walnut inlay on an endgrain teak cutting board. And just to show you what I was looking at throughout the process, this is a cutoff from the same cutting board. I didn't realize how much darker it would get when I applied an oil finish at the end of the process. And when I was laying everything out, there seemed to be a good amount of contrast between the teak and the walnut, but that was before finishing. So when I applied an oil finish, everything just kind of blended together. All that to say, it's important to be mindful of your materials when doing an inlay because you want contrast. Contrast is kind of the whole point. Anyway, the inlay itself came out pretty good, so let's move on. Since this was my first inlay, I wanted to do one that was complex and detailed enough to be challenging, but not so crazy I'd be setting myself up for failure. So I decided to make an endgrain cutting board with an inlay of a diagram of a cow showing where to find all of its most delicious parts. After gluing this board up all endgrainy, I put it on the CNC and created a pocket tool path encompassing the entire surface with a little bit of margin around every side, cutting 0.03 inches deep across the entire surface to flatten the one side. And the bit I'm using to flatten is a 3/4 inch diameter, 1/4 inch radius bowl and tray bit from Bits and Bits. That may not be and probably isn't the best bit to use for that, but someone on the internet said it would be great, so I went with it. Because this bit has a relatively large diameter, I dialed down the speed on my Makita router to about the 3 mark. It'd be cool if there was an easy to translate system that correlated the number on the dial to RPMs, but I had to Google it. The recommended speed for this bit is 16,000 RPMs with a feed rate of 120 to 150 inches per minute. When programming my toolpath, I set my XY datum to the center of the material because I staggered the strips when gluing this thing together, and I didn't have a nice square corner for my 3-axis touch probe to get a good reading. Now I have a nice flat piece that I can confidently set my Z-axis to and run my toolpaths. And this is super important because when you're doing inlays, the tolerances are so tight, everything has to be nice and flat for it to come out right. Now that I had a blank canvas on which to carve my masterpiece, I imported a fairly simple vector I downloaded from the internet. It was free, and we'll put a link in the description if you want to use it too. I centered the design to the center of the material and made sure to join any open vectors. I grouped everything that would be cut the same way and started working on my toolpath. And in doing so, there was a lot of trial and error, mostly error. It was mostly error for the simple fact that I was listening to all these perfectly competent guys on YouTube, but I didn't understand the terminology. And they were talking about start depth and flat depth, and I just wasn't there yet. So after messing around with it for a little while, here's the best way I know to explain it. You've got your male part and your female part. The object that the inlay is going into is always going to be the female part, and the inlay itself is the male part. Actually, you know what? From here on, I'm going to refer to the female part as negative and the male part as positive, just to keep myself from giggling through this whole thing. The idea is to get the positive side of the inlay to nest into the negative side of the inlay with no visible gaps on the surface where the two parts meet, the surface that'll be visible. I used a tapered ball nose bit with a 1/32 inch radius tip from Tool. The tapered ball nose bit will give me very slightly tapered walls, forcing the positive side to center itself in the negative side as it's inserted. To do that, and this might be common sense and maybe even not worth mentioning, but it's very important that you use the same bit to cut both the positive and negative sides of the inlay. It's not recommended, it's absolutely necessary. Let's start with the negative side of the inlay. In V-Carve, I'm going to select my design and create an engraving toolpath. The start depth on the engraving is going to be 0. That just means we're starting at the top surface of the workpiece. The cut depth will be 0.3 inches, and that's just a little over 1/4 inch. Under Tools, we're going to either import the specs for this bit or input them manually. If you input them manually, make sure that the specifications are accurate and directly from the manufacturer. If you just take a wild guess at it, you're not going to get good results. I set my feed rate to 80 inches per minute because the tip of this bit's pretty small, so I don't want to push it too hard. We'll go ahead and preview that toolpath, and looks like everything's going exactly how I wanted it to. After I put my inlay in there, I'm going to want to give the whole thing one more flattening, just taking about 0.010 of an inch off the top to make everything nice and flush and not change the appearance of the inlay design. But we'll get to that later. All right, now let's move over to the positive side of the inlay. This will be cut out of a different piece, so I just set up a whole new project for it. When you import the design, you want to center it to the material and mirror it horizontally. Remember, the top of the positive part is going to be at the bottom of the cavities that we engraved, so the image needs to be reversed. Now, after the positive side's all cut out, you'll need to separate it from the waste. So the easiest way to do that is to select your design and create an offset by clicking the offset button over here on the left. That'll generate a new vector around the outside of the design, and I set mine to a 1/2 inch. I know I'll be cutting this thing out on the bandsaw, so a 1/2 inch just gives me a good amount of space to work with. Now, instead of an engraving toolpath, we're going to select both the design and the offset and create a pocket toolpath for the positive side. This will remove all the negative space around the positive parts of the inlay. In researching how to do this, despite all the conflicting information, one thing was consistent. For the positive side of the inlay, the start depth and the cut depth have to equal the cut depth of the negative side, which in this case is 0.3 inches. So for the positive side, I set the start depth to 0.28 inches and the overall cut depth to 0.02 inches, totaling 0.3 inches, all said and done. Don't ask me why that works, I don't know. It just works. Now with the same bit and the same XY origin, because I didn't move my stops, all I had to do was probe for Z. So I probed for Z. Then I ran the program. After the operation was complete, I brought it over to the bandsaw to separate my inlay from the waste around it. Now I had my inlay just about ready to put it into the cutting board, but first I went through and just kind of cleaned up the edges to make sure there was no fuzz or anything that would prevent the inlay from fully seating in the pocket. Once you're happy with how the inlay looks, it's always a good idea to dry fit it before applying any glue. Just make sure that it fits and there aren't any gaps on the top surface where the two parts meet. Then just put some glue in there, spread it around real good, and insert your inlay. It should sit in there just fine with a few good taps, but feel free to use clamps if you like. While I was waiting for the glue to dry, I created a separate pocket toolpath to get rid of the material sticking out above the inlay. So I measured how far the waste material stuck up above the cutting board and made the flattening toolpath to just cut about 5/1000ths of an inch shy of that. After that, I ran one last flattening toolpath across the whole thing. I then routed a round over to the top edges and a 30-degree chamfer to the bottom edges. And then I sanded. And I sanded, sanded, and I sanded some more, and sanded, until I got to a point where I was just tired of sanding. I was done. Finally, I slapped on some oil and wax finish and called it a day. Now that it's done and I don't even really like it, maybe I'll give it to Darlene. Well, that about does it. I hope you found this helpful, and if you've been wanting to start doing wood inlays, this should get you on your way. All right, I'm out of here. Make sure to like the video, subscribe to the channel, comment, hit the notification bell, all the stuff. You know the drill. Thanks for watching. Y'all be good.